Okay, hello my students, friends, and all of the followers. In today's video, I'm gonna show you how to solve this equation and then this equation algebraically, and then you should be able to solve any kind of the absolute value equations. Okay, so let's start with the first one, but in the meantime I'm not gonna use this, so I will just put it here for having it later on. Now, as you know from my previous videos, the first step you do, you look for the key points or 0 points, which means this is basically x coordinate of the graph of each absolute value function, which is here. So basically it means our first 0 point is x equals 0, and the second one is x equals, if you can calculate by head, you can very easily see that x must be equal negative 3 over 2. If you don't see it easily, you still have to train yourself and you have to solve this simple equation when 2x plus 3 is equal to 0. So take away 3, 2x is equal to negative, is equal to negative 3 times 1 over 2, which means x is really equal to negative 3 over 2. So this is how you find the 0 points. If you can do it quickly, you just write the value and you can go to the next step. The next step we were talking about, and I explained you how and why to do, is to split the number line so that you can very easily identify the intervals for both expressions. So this is the number line representing these two numbers, and then there comes the table thing where you find what is the absolute value equal to for different x's from different intervals. So the first interval, as you can see from this number line, is from the negative infinity, okay, to negative 3 over 2. The second interval, as you can see, is from negative 3 over 2 to 0, which means negative 3 over 2 to 0. And our last interval, as you can see, is from 0 to the infinity. So 0 to the infinity. So these are my intervals where I'm looking for what the expression is absolute value of x equal to, and the second 2x plus 3 is the same procedure. So as you can see, you take any negative number from this interval. So let's take negative 10. The value of negative 10 is negative number, which means absolute value of x is calculated by minus x. The same applies for the second interval. The clever idea here is to take negative 1, which is also negative number, which means the expression or how to calculate the absolute value of x for the numbers from these two intervals is to take the opposite expression. And if you take any positive number, it's going to be positive number, so the representation is with the expression x. Now the second one can be more challenging, but I think maybe not. If you take again like a big negative number, in this case for example negative 10, negative 10 times 2 is negative 20, plus 3 is definitely negative number, so the expression is going to be negative 2x minus 3. If you think about this one, you again take negative 1 number, which is going to be negative 2 plus 3, it's going to be positive number, so the expression is 2x plus 3, and the same applies for the last interval. You take positive 10, so 20 plus 3 is positive 23, so the representation is again 2x plus 3. Now let me, as I need a little space, I will do it this way. We start with the calculation or 0.4 here, which means you now again cooperate with the table. So for each x from the interval negative infinity to and negative 3 over 2, the equation, this one, okay, we are working with this equation, means that it's gonna be calculated like this: negative x minus 2x minus 3 is equal to 6, which means negative 3x, and you can do it like really quickly in one step. Negative 3x is equal to 9, so times 1, no, okay, times negative 1 over 3, which means x is equal to negative 3. Okay, double check. You really have to ask yourself if negative 3, let me use red color, if negative 3 is from this interval. Yes, it is. Then you can make the conclusion that our set of the solution for the first interval or for the first case is one element set, negative 3. So this is my first solution. Next thing we have to do is to find what is x equal to if x is from the interval negative 3 over 2 to 0. And it's gonna be the second column, so my equation will be negative x plus 2x plus 3 is equal to 6. To solve this equation, you can see very easily that you can again take away 3, and if you simplify this expression, it's gonna be x is equal to 3. Okay, so this is the solution of this equation, but above the whole real numbers. And now really comes the thing you have to do. You have to check if number 3 is from this interval, and as you can see, number 3 is not from the interval negative 3 over 2 to 0. That means the K2 is equal to the empty set, because number 3 is not from the interval we are calculating with. Okay, so this is it. Now let's have a look and to calculate the last equation. So for each x from the interval 0 to the infinity, my equation is gonna be x plus 2x plus 3 is equal to 6. Again, let's do it quickly. Take away 3, so 3x is equal to 3, which means times 1 over 3x is equal to 1. Let's have a look. Let's do the quick check. 1 is from this interval, so it means it is a good solution for us. So K3 consists of number 1, so it's one element set. Okay, now to really find out if what is the solution of for the equation we are solving, we have to do K1 union K2 union K3, which means it's gonna be two element set, and the solutions are negative 3 and 1. Okay, if you want to, you can do the check right now. Let's do it. So our check is gonna be for left side, for x being negative 3, which means it's gonna be absolute value of negative 3 plus absolute value 2 times 2 times negative 3 plus 3 in absolute value, it is equal to 3 plus, this is gonna be negative 6 plus 3, so it's negative 3, but the absolute value of this is number 3. So we are okay now. 3 plus 3 is equal to 6. Right side for negative 3 is equal to 6. Okay, so left side is equal to right side, fine. Now let's do the check for the left side for x being 1, which means we have the absolute value of 1 plus absolute value of 2 times 1 plus 3 is equal to, and it is 1 plus 2 plus 3 is 5, so it is again number 6. We are fine, up. So the right side for 1 is 6 as it is constant, which means left side is equal to the right side. So our calculation is correct, and this is really the solution of our first equation. Okay? Good. Now let's have a look on the second equation, which looks a little bit more complex. So let's see what the result will be. And we don't need this anymore, so let's get rid of this. Okay, let's delete everything so that we have enough space, and now we'll be solving this equation. And as you can see, this is really something you just learn and then you repeat the steps. There is nothing like to not do properly, but I ask you to watch the previous videos so that you can really understand what's behind this calculation and why this algorithm is like working and why do we use it. Okay, so as we already know, our first step is to find the 0 points, which means the first 0 point is negative 4 over 2, which is negative 2. And the second 0 point is x is equal negative 2. Yes, negative 2 over 3. Let me just check and show you how did I do. So 2x plus 4 is equal to 0. 2x is equal negative 4. X is equal negative 4 over 2, which is negative 2. This one is the first, so we are correct. And let's see the second one, 3x plus 2 is equal to 0, which means 3x is equal to negative 2, which means x is equal to negative 2 over 3. So we are okay here as well. Now the next procedure, the next step, if you still need this, you can sketch the number line, which basically means here is my negative 2, here is my negative 2 over 3, and by the way here is 0, but we don't need this information, so this is like the next step, which you can or you don't have to use it if you are quite familiar to with how to construct our table, which is important thing. So we will be looking for absolute value 2x plus 4 expression or representation and absolute value 3x plus 2 on these three intervals from negative infinity to negative 2, the second interval negative 2 to negative 2 over 3, and the last interval is from negative 2 over 3 to the infinity. Okay, so let's take the big number. Negative 10 is a good choice. Negative 20 plus 4 is definitely negative number, so negative 2x minus 4. Negative 30 plus 2 is definitely negative number, so it's gonna be negative, negative 3, take away 2. Here there is only one reasonable number which we can take, and it is negative 1. So negative 2 plus 4 is definitely positive number, so it is gonna be like 2x plus 4. Negative 3 plus 2 is negative 1, which is definitely negative number. Negative 3x minus 2, and the last is 2x plus 4, and here the reasonable number is 0. So 0 plus 2 is definitely positive, so it's 3x plus 2. You can have a look on this table. This is something I want to mention. You can have a look on this table, and if you think about this table and the expressions there, you can realize that there are all combinations. that are possible. Okay, so this is like quite quick check. You can find out if you really did it properly, and if you will do a lot of training, you will also come familiar, and you will do this like really very quickly, because you're gonna start being bored. Boring. It's gonna be boring for you. Okay, so the fourth and the last step is we find the solution of our equation for each x from the interval negative infinity negative 2, which is then the equation negative 2x minus 4 minus, and here is something which is really important, and that's why I have chosen this equation. You have to be aware of negative sign in front of this absolute value. So I prefer, and I think it's a good manner to write negative and then use the parentheses and then use the expression from the table. Or if you are really skillful, you can see that this is gonna be opposite expression. I'll explain in a couple of seconds. So I prefer to have negative and then parentheses, and then I simply take the negative 3x minus 2 is equal x minus 1. I was explaining in previous videos why this is nothing that bothers us in the manner of 0 points or the table, because this is function which remains on the whole domain, or for real numbers it has the same value, so you put x. The number instead of x, and you simply calculate the value. So now let's simplify this. So it's gonna be 2x minus 4, and now this is what I was explaining a couple of seconds before. As this is minus, then it will become plus 3x plus 2 is equal to x take away 1. So you can, if you are really skillful and you see it and you are like really brave and you believe in yourself that you won't do it like wrong, then you can start with this line immediately. Okay, so let's simplify the expression on the left side. It's gonna be x minus 2 is equal x minus 1 minus x plus 2, which means 0 is equal to 1. We already know what this means. This means that we don't have the solution of our equation for x's from this interval. The case may be all the three lines which are represented by these three functions are parallel, and yes, I think they are. So this is the solution, which means k1 is equal to empty set. Okay, the next step is for all x's from the interval negative 2 to negative 2 over 3. Our equation will be 2x plus 4 minus, again I will use the parentheses, negative 3x minus 2 is equal to x minus 1, which means 2x plus 4 plus 3x plus 2 is equal x take away 1. So simplify the expression on the left side is like 5x 5x plus 6 is equal to x minus 1. So minus x minus 6, it means 4x is equal to negative 7, which means times 1 over 4, x is equal to negative 7 over 4. Now we have to check if this number is really from this interval. Is it? Yes, it is, of course. So it means because it's less than 2, if it would be less than negative 2, if it would be negative 2, then it would be negative 8 over 4, and it's more than 1, so we are really fine here, which means k2 is one element set with the number negative 7 over 4. So this is our first solution. Our second solution, let's use the space here. So the last thing is we are working on this interval, so we take all the information from this interval. For each x from the interval negative 2 over 3 to the infinity, our equation is gonna be like 2x plus 4 minus 3x plus 2 is equal to x minus 1. Let's simplify the expressions. 2x expression 2x minus 3x is negative x. 4 minus 2 is plus 2 is equal to x, take away 1. So let me do it like this. Okay, minus x minus 2, which means negative 2x is equal to negative 3. Now we do the multiplication times negative 1 over 2, so x is equal to 3 over 2. Okay, so this is our solution for this equation for all real numbers, but we have to do again the quick check. If this number is from this interval, as far it is positive number, we can see very easily that the answer is yes. So it means K3 is again one element set, and it consists of number 3 over 2. And now we make the final conclusion. So K is, we already know K1 union K2 union K3. You don't have to write it anymore, but just keep it in mind. I'm okay with that. So K is 2-element set, and it is numbers negative 7 over 4 and 3 over 2. Okay, guys, this is almost everything about the solving absolute value equations. Now it's time for you to do a little bit of training, and let me just write some kind of equations you can try to solve, which are, for example, the equations you can try by your own. The equation absolute value x take away 6 minus absolute value x plus 1 is equal to 2x. This can be the first one. You can try x plus 7 minus 2x is equal to 3 times absolute value minus 2. And if you want to, this would be really something to try with 3 absolute values, x plus 1, 5 plus 2 is equal to 2 times 4 take away x minus absolute value of x. So these are the 3 absolute value equations I want you to try. And I'm gonna maybe leave the solutions in the comment of this video, so that you can check if you did calculation like properly and correctly. Okay, so thanks for watching and enjoy solving absolute value equations. Bye.